You are listening to The Vocal Technologist. Spoken tech for your ears.
What if I told you that you could just tell your laptop to handle your afternoon meetings, process your monthly expenses, sort out that lingering supply chain email thread, and it just, well, did it?
Yeah, no clicking, no dragging.
Exactly. No typing out replies. It just happened. Now, you might reckon that sounds like pure science fiction.
Oh, absolutely.
But Mark Zuckerberg is literally building an AI clone of himself to replicate his mannerisms, his tone, and his public statements, just to sit in on meetings for him.
It is a profound shift in how we interact with our machines. We're moving entirely away from the era of the computer as, a passive tool just waiting for your keystrokes.
And that is the absolute core of our mission here. We are going to unpack the massive transition happening in technology.
We really are.
We're moving from AI being a passive chatbot that you type questions into to an active autonomous system that completely controls your operating system.
Right, that takes the wheel.
Spot on. We are going to pull apart both the software that is making this autonomous future possible and the trillion-dollar hardware scramble happening behind the scenes to keep these digital systems alive.
It is a massive undertaking.
It really is. So let us look under the hood of the software side first, because we are essentially looking at the death of the traditional operating system.
We really are. And to understand what is replacing it, we need to look at what companies like Perplexity are building.
Okay, what are they doing?
Well, they have launched a platform they are quite literally calling Personal Computer, and OpenAI is running right alongside them, updating their codex model with background computer control and web browsing.
Oh, wow.
Yeah. Google is also building its own desktop agent. What all these platforms share is a shift from executing manual instructions to what we call probabilistic goal completion.
Okay, let us unpack probabilistic goal completion for a second, because that sounds like a massive mouthful of jargon.
It does, yeah.
I mean, if I am using a computer right now, it is entirely deterministic.
Right.
If I click a folder, the folder opens. If I drag a file into an email, it attaches. I am manually driving the process.
Right. You are issuing a rigid, hard-coded path of commands. Probabilistic goal completion throws that out the window entirely.
Okay.
When you give an agent a goal, say, find the Q3 revenue numbers, format them into a chart, and send it to the board, it does not have a pre-programmed script for that.
So what does it do?
Instead, it calculates the most probable sequence of actions to achieve that outcome across all your various fragmented software tools. It guesses the best path, evaluates the result of its first step, and then recalculates the next.
Wow.
It turns the computer into an active orchestrator.
So to put this in perspective, this is like upgrading from a manual transmission car. For decades, we have been driving computers manually. You have to push the clutch, shift every single gear yourself. What Perplexity, OpenAI, and Google are building is essentially climbing into the back seat and just telling the chauffeur your destination. You do not care what streets they take, you just want to arrive.
But the chauffeur in your analogy is constantly analyzing traffic, weather, and road closures in real time to get you there.
Right.
To make this work, these agents are utilizing deep web research as their core foundation. They are not just blindly clicking around, they're autonomously evaluating their own reasoning paths.
So they check your own work.
Exactly. They research how to use an interface, evaluate the steps, and then drive the multi-step workflow.
I hear that, but I have to push back a bit because I am highly skeptical of how smooth this ride actually is.
Fair enough.
Does this actually eliminate friction for you? Or are we just creating a brand new job for ourselves? Like, are we just going to become professional babysitters, constantly monitoring these probabilistic agents to make sure they do not hallucinate a workflow and accidentally email our tax returns to the entire marketing department?
That is a very real concern, and the industry is incredibly aware of that tension. When a system operates probabilistically, there is a margin of error baked into the math.
Right, because it is guessing.
Exactly. If an agent tries to click a submit button, but the software vendor updated the interface overnight and moved the button 2 pixels to the left, a rigid script breaks.
Oh, I hate when that happens.
Right. A probabilistic agent tries to recover by scanning the screen for something that looks like submit. But if it gets confused, it needs oversight. Google's desktop agent actually includes a require human review toggle for this exact reason.
Which brings me back to Zuckerberg's meeting clone. Because apparently that is where we are now, sending our digital ghosts to sinks.
Yeah, it is wild.
We are trusting probabilistic code to accurately represent our tone and decisions in a room full of other people. Or perhaps a room full of other digital ghosts.
It is a strange new world.
It feels like the administrative friction of managing our tools is disappearing, but the cognitive load of verifying their intent is skyrocketing.
And that cognitive load of verifying intent requires a massive safety net. Because when an agent calculating probabilities gets it wrong, it does not just stop.
What does it do?
It can cascade into a series of highly confident mistakes.
Oh, brilliant. Just confidently ruining my spreadsheets.
Exactly.
Speaking of which, if we are handing over the keys to the car, what happens when the AI drives into a ditch? Or worse, drives somewhere it absolutely should not? When those confident mistakes happen, how does the system course correct without burning down your workflow?
It turns out it raises its hand.
Wait, really?
Yes.
Wait.
We are seeing the emergence of entirely new infrastructure to handle agent failures. The most fascinating example is a platform called Homework. It is essentially the first agent-to-person marketplace.
Agent-to-person. Okay, walk me through how that actually functions.
Well, when an AI tool, like Anthropic's Claude Code, is orchestrating a complex software engineering task and gets hopelessly stuck, it does not just throw up a generic error message for the user to decipher.
Thank goodness for that.
Right. Instead, it actively packages up its context and hands the task off to a verified human expert on the Homework platform.
Like calling tech support for itself.
Precisely. In under 30 seconds, a human logs in, untangles the mess, completes the step, and hands the reins back to the AI to continue processing.
It is exactly like using a self-checkout machine at the supermarket.
Oh, that is a great way to look at it.
You know, you're scanning your items, everything is great, and then you put a weirdly shaped onion on the scale.
Right, the machine panics.
The machine gets hopelessly confused, flashes a giant red light, and you have to stand there until a tired human manager comes over, swipes a card, punches in a code, and tells the machine, yes, it is just an onion, please continue.
Exactly.
We are building that exact dynamic, but for enterprise software engineering.
Your supermarket analogy highlights a crucial mechanism, though. The human manager swiping their card.
Okay.
They have the administrative authority to override the system. When we scale that to enterprise software, the security implications become massive.
Oh, I can imagine.
If an autonomous agent is moving through a company's systems, trying to complete a goal, it needs permissions to access repositories, databases, and communication channels.
Which terrifies me, straight up.
Understandably.
Giving agents deep system access is like handing the brand new intern the master keys to the entire office building and then frantically running around trying to install new locks on all the sensitive doors before they accidentally walk into the server room and spill coffee on everything.
That is a very vivid but accurate picture.
I mean, if an AI is escalating a ticket to a human on Homework, it means that AI was already poking around inside sensitive code bases.
And that vulnerability is exactly why the security sector is scrambling to adapt. Cloudflare, for instance, is rolling out infrastructure specifically designed to secure what they are calling non-human identities.
I just need to pause and react to the phrase non-human identities.
It is a bit dystopian.
It is completely wild. I
Yeah.
mean, we are now issuing employee credentials to lines of code. We are treating software as digital employees that need to be authenticated at the door. How does Cloudflare even lock that down?
Well, they're introducing scannable tokens to protect credentials, along with what is called resource-scoped role-based access control, or RBAC for short.
Okay.
They are also giving security teams OAuth visibility to manage these non-human principles.
Let us break down those acronyms for a second. RBAC and OAuth. How do those act as the lock on the door?
Think of OAuth like a hotel T-card system.
Okay, I am tracking.
When you check into a hotel, they do not give you the master metal key to the building. They give you a temporary digital token, the key card.
Right.
RBAC, or role-based access control, scopes the permissions of that card. It dictates that your specific card only opens room 304 and the gym, but it will not open the manager's office or the kitchen.
Ah, that makes sense.
Cloudflare is building this exact hotel keycard system, but issuing the cards to autonomous AI agents, ensuring they only have the exact permissions necessary for their specific task and not an inch more.
Which is absolutely necessary, because you do not want your expenses agent suddenly deciding it needs access to the HR payroll database just to calculate a flight reimbursement.
You definitely do not. But we have to lock these systems down because we are approaching a very specific tipping point known as the mythos threshold.
Okay, the mythos threshold. What exactly crosses that threshold?
The mythos threshold refers to the point where an AI crosses from being a predictable tool that executes tasks to exhibiting genuinely unforeseen autonomous behavior, particularly in cybersecurity.
Unforeseen behavior. That sounds ominous.
It is named after Anthropic's unreleased mythos model. The reasoning capabilities of that model in terms of threat detection were so advanced and its autonomous behavior so unpredictable that Anthropic briefed the government on its capabilities.
Wait, really?
Yeah. It represents the moment a system's reasoning becomes advanced enough that traditional perimeter defense simply breaks down.
That is a staggering reality.
It is.
When a piece of software can independently evaluate a network, discover vulnerabilities, and autonomously write patches or exploits, the threat is not just someone hacking in from the outside. The agent is already inside the house, operating with its own set of non-human credentials.
Which forces security to move from protecting the border to verifying every single action inside the network.
That sounds exhausting for the servers.
Oh, it is. Maintaining that level of continuous verification while simultaneously running millions of probabilistic agents for everyday workers demands a massive physical toll. We talk about software as if it exists in the ether, but it is grounded in steel, silicon, and immense amounts of electricity.
And this is where we transition from the software into the physical reality.
Yeah.
Because hang on, to run millions of these non-human identities, to have autonomous systems scanning networks constantly, you need an incomprehensible amount of raw computing power.
You do.
And from what the numbers show, we are literally running out of it.
The physical bottleneck is perhaps the most defining constraint of this entire technological shift.
How bad is it?
The scale of capital deployment happening is unprecedented. Currently, just 5 hyperscalers own over 2/3 of the world's AI compute. That is Google, Microsoft, Meta, Amazon, and Oracle.
Let us just sit with that for a second. 2/3 of the global infrastructure for the most important technology of our era is controlled by 5 companies.
It is a massive concentration of power.
The financial figures attached to this are staggering. OpenAI is spending over $20 billion on chips from a manufacturer called Cerebras and dropping another $1 billion just to help fund the development of the physical data centers to house them.
It is an absolute arms race for raw infrastructure. Microsoft has taken over a massive 230-megawatt data center facility in Norway, operated by Niscale.
Wow.
And that is specifically to house 30,000 NVIDIA Vera Rubin GPUs. To put 230 megawatts in perspective, that is enough power for hundreds of thousands of homes entirely dedicated to a single building of servers.
It's just hard to fathom.
And meanwhile, Meta is committing to 1 gigawatt of custom chips with Broadcom.
1 gigawatt. They are using the electricity equivalent of a medium-sized city just to process matrices of numbers.
Exactly.
The sheer scale of this is hard to wrap your head around. It feels like the digital equivalent of a gold rush.
It really does.
But in this scenario, the real money is not in finding the gold. It is in being the only company that manufactures the shovels, which is NVIDIA, and owning the only railroads that can get you to the mine, which are these hyperscaler data centers. They are literally hoarding the physical infrastructure of intelligence.
That gold rush analogy is highly illustrative. What we are witnessing is the dawn of compute scarcity.
Compute scarcity, so we were running dry.
Yes. For the last 20 years, the tech industry operated on the assumption of infinite cheap computing power in the cloud. That era is definitively over.
Wow.
Access to bleeding-edge compute is rapidly becoming a gated privilege. The reason these GPUs consume gigawatts of power is because of the fundamental mechanics of how AI models work. They rely on complex matrix multiplication,
Which is basically multiplying billions of decimal numbers together simultaneously, over and over again.
Exactly. It requires massive energy and generates incredible heat.
Which explains why the metric of success for hardware providers like NVIDIA has completely shifted. You do not hear them talking about raw processing speed in the same way anymore.
They do not, because raw speed is not the bottleneck anymore. Efficiency is.
Right.
The only metric that actually matters for real-world, profitable scaling is cost per token. It is not about floating point operations per second per dollar anymore. It is about how efficiently you can deliver a single unit of intelligence.
So they have to make it cheaper to run.
Exactly. NVIDIA's entire strategy with their new Blackwell platform is centered on drastically reducing that cost per token, because if the power draw continues to scale linearly, the grid will simply collapse.
And the pressure around this supply chain is immense. We saw NVIDIA's CEO, Jensen Huang, lose his composure during an interview when discussing whether sales of advanced chips should be restricted in China.
It is a very sensitive topic.
It is. The fact that extra controls on silicon can provoke such a visceral reaction from the head of the most valuable hardware company in the world just illustrates the sheer geopolitical weight of these components.
The supply chain for advanced AI chips is incredibly fragile and highly concentrated. When compute is scarce, and access to that compute equates to massive economic and cybersecurity advantages, the hardware ceases to be just a commercial product.
What does it become?
It becomes a critical geopolitical asset.
But here is the massive problem. Since we cannot just infinitely build gigawatt data centers without eventually boiling the oceans, the math has to change.
It absolutely does.
We have to get smarter, not just bigger. If we want these autonomous agents to actually function for everyday tasks, to run on our laptops and phones without requiring a direct link to a nuclear power plant, we need a massive pivot.
And that pivot is happening. Brute forcing intelligence with sheer scale is hitting physical and thermal limits. So the research community is shifting hard. The next phase is all about algorithmic efficiency.
And we are seeing breakthroughs in doing more with less that almost sound impossible.
Let us look under the hood of a new language model family called ternary bonsai.
Oh, this is a fascinating one.
What is wild about this is that it is a 1.58-bit language model. Because it uses such minimal memory, it can run with massive energy efficiency directly on consumer devices like your Mac or your iPhone.
To understand why 1.58-bit is such a massive leap, we have to look at how models traditionally function. A standard AI model uses 16 bits of precision for its weights.
Okay.
It is dealing with long, complex decimal numbers. Multiplying those decimals requires intensive, power-hungry operations. By reducing the architecture to 1.58 bits, researchers essentially restrict the model weights to just 3 values.
Which are?
-1, 0, or +1.
Wait, really? So instead of doing complex decimal math, it is just adding and subtracting whole numbers?
Exactly. You eliminate the need for complex matrix multiplication entirely and replace it with simple addition.
That is brilliant. The energy savings are astronomical, and it drastically lowers the barrier to entry for running these models locally.
Which means you do not need a massive hyperscaler cloud to run genuine intelligence. You do not need Microsoft's 230-megawatt Norwegian data center just to have an agent sort your emails.
You really do not. And researchers are fundamentally rethinking how we feed these models data as well.
Oh, so?
Well, Apple published a fascinating paper called Cram Less to Fit More. They proved that pruning training data, actually giving the model fewer facts to learn from, improves its ability to memorize the facts that matter while drastically reducing hallucinations.
It is exactly like studying for a university exam.
So.
Well, if you try to memorize the entire textbook word for word, your brain just turns to mush. You do not need the entire encyclopedia to be smart. You just need to know exactly which pages actually matter.
That is a great comparison.
If you trim all the excess reading, your recall of the important facts becomes vastly sharper. You cram less, but you fit more relevant, actionable knowledge into your brain.
And when you combine that highly refined data diet with new architectures, you fundamentally change the execution dynamics. Beyond the 1.58-bit models, we are also seeing breakthroughs like introspective diffusion language models.
Okay, introspective diffusion language models. Break that down for me, because it sounds like a psychology term.
It does, yeah. Traditionally, language models are autoregressive. That means they generate one token, or one word, at a time, sequentially.
Yeah.
It has to wait for word A to be generated before it can predict word B. It creates a massive bottleneck in processing speed. Diffusion models promise to break that sequential bottleneck by generating multiple tokens in parallel, all at once.
Right, doing all together.
But early attempts suffered from quality issues because the generated words would not agree with each other. The new introspective diffusion models solve this by verifying previously generated tokens while advancing new ones in the exact same forward pass.
So instead of writing a sentence word by word and hoping it makes sense at the end, it is generating the whole sentence at once and instantly double-checking its own grammar and logic while it writes.
Yes. They achieve bit-for-bit lossless acceleration. They maintain the quality of the slow, sequential models, but operate at a fraction of the time and compute cost.
That is an absolute revelation.
It is. This means we are breaking the reliance on those gigawatt data centers. By scaling algorithmic efficiency rather than just physical hardware, we are enabling high-level autonomous intelligence to run locally, securely, and efficiently on the devices we already own.
Which really brings this entire transition full circle. We are moving away from an environment where we have to manually command our machines into a reality where our operating systems orchestrate complex goals probabilistically.
Exactly.
We are navigating the absolute security nightmares of non-human identities, relying on human experts to untangle confused AI when it gets stuck.
Yep.
And beneath it all, we are watching a massive geopolitical tug-of-war over the physical chips required to power it, while brilliant engineers simultaneously figure out how to compress that intelligence down to fit in our pockets.
It is a complete redefinition of the relationship between human intent, software execution, and physical computing resources.
So I want to leave you with a thought-provoking question to keep turning over in your mind. If your personal computer starts delegating its tasks to autonomous agents, and those agents encounter friction, and human experts are being hired specifically to unblock those agents so they can finish your work. Wait, let me rephrase that. If human experts are just working to unblock the AI doing your job, who is actually working for who? Are we automating our jobs, or are we just becoming the IT support staff for our own digital ghosts sitting in Mark Zuckerberg's meeting rooms? Keep exploring from your vocal technologist.
Spoken Tech for your ears.